So hi, I'm Daniel Rusev, and I'm an IoT architect, and I help companies and organizations to develop an overall IoT ecosystem engagement strategy while leading the way through vision, architecture, and shepherding them from inception to deployment. Sensors, software, connectivity, devices, how you onboard thousands of devices, how you secure the traffic, collaborating all together in one ecosystem, which is which I'm trying to help to automate industries, improve our cities, and for a better life. How to begin? How to move fast from concept to reality? And sorry, today I want to show you something more than reading sensors and showing value in a web browser. I want to show you the place where Internet of Things meet artificial intelligence, and I will demonstrate how you can achieve facial recognition with low-cost hardware. And here is how I'm going to do it. First, I will go through the tools, hardware tools that we're going to use, how you set up the tools, how you install the operational system, software, and so on. Then I will go through the software tools that we're going to use, platforms, SDKs, APIs, and etc. Then I will explain about the core. One of the core tools that we're going to use is the AWS video streaming SDK, Eclipse Kura, the serverless cloud architecture that actually will process the data stream from this device. And yeah, I will demonstrate how face recognition really works. Just a few words before we start. How many of you are working in the Internet of Things area? Okay, nice. So you probably already know that IoT is already integrated at a certain level at our everyday life. And the next big tech revolution that everybody is talking about these days is how we combined Internet of Things with artificial intelligence and what insights we can get from it. And the world is becoming more and more intelligent, more responsive to our needs. So when everything becomes linked with everything else, as Derek Davis used to say, matter becomes mind. It's really interesting topic about me. And yeah. Okay, so let's go through the tools that we're going to use. I'm going to use a regular Raspberry Pi 3, Raspberry Pi camera module. We're going to use a battery pack, but you can also go with the standard charger. And I've also put it into a 3D printed shell. So just for. And more tools. One of the tools that we're going to use will be the Eclipse Kura. How many of you are familiar with Eclipse Kura? Okay, so it will be a nice. Actually, Eclipse Kura is an open source tool. The main players who contribute to the project is Red Hat and Eurotech. Also, we're going to use the AWS services like Rekognition, Kinesis streaming. Something very interesting about Kura that is based on OSGi framework. So, are you familiar with OSGi? Okay, so yeah, will be. And also we'll go through the topic of Eclipse Kura, which is also a free and open source platform for Internet of Things, where you can connect devices, manage them, connect them in a secure way, manage them, and then integrate with other platforms. Okay, so. First, about the architecture, we're going to see under the hood of Eclipse Kura what it is, how it works, how you install it, how you deploy it to the device, how you connect your environment to the target device, how you upload bundles to it, and yeah, how the whole workflow works. And we're gonna see some nice features that are really new, which is the Kura wires, which is actually in a diagram flow where you can prototype your application really fast. Just in a matter of minutes, you can have a running application. And we also will take a look about the architecture for the application itself and the cloud. Okay, so Eclipse Kura, just to mention a few words about it. Eclipse Kura is it's an IoT project. It's a platform for building IoT gateways. So what it looks like is a set of tools that you deploy to the target device. Currently, it's a Raspberry Pi, but it can be any other gateway where you install all those tools, and it runs on the bottom is the OpenJDK. Then we start with the OSGi application container, which is a very nice tool, give you the possibility to manage modules. So you can have bundles which consist of very small modules. They work together, and you deploy them separately from other applications, so they do not interfere with any other part of the system. And then the device abstraction. This is the actual driver that connects to the hardware, so you can access the GPS, you can access the GPIO, you can access the other serial interfaces. And then we go to the basic gateway service. We have like a clock service. We have a watchdog. This watchdog actually check the health status, and we have you can have like device profile and so on. And the network configuration. You have like different configuration for cellular, for Wi-Fi. Actually, for the Wi-Fi, it's pretty interesting because you can use this device as a hotspot, and let's say you can have other devices that connects to the gateway through Wi-Fi, and you can push data to it. Or you can use it just like a gateway and use the Wi-Fi connection to bring it to the world, to connect it to the internet. And you have like firewalls, you have port forwarding, all those nice features that can really bring your application to the enterprise. And yeah, connectivity and delivery is the next bit, which is also nice. You have a lot of adapters where you can seamlessly connect to almost any cloud. You can connect to AWS. You can connect to Eurotech Cloud or any other service provider. And also you have integrated MQTT broker to push the data to this cloud. And on top is your application, which actually it's running in bundles. And yeah, the remote management. This is the tool which actually manage your application's lifecycle when you deploy it, how you change the version, upload it, and all other features that are okay. So this is the architecture for the Kura wires. This is the environment for data flow programming, where you can have the logic expressed in a graphs. So you can have like different boxes. Let's say you have a box which connects to a sensor, which actually is the drivers. You can connect to those devices with different protocols, and you have the asset management, which give you actually the possibility to play with those devices in a visual way. And okay, the architecture of our application, yeah, will be we have our Raspberry Pi that have like the small camera module in front of it. We're gonna stream data to AWS Kinesis, and we're also gonna use AWS REKOGNITION, the blue. And I've also prepared a set of uploaded pictures, predefined faces that system will recognize. And then for a notification to the user, we have Kinesis streams calling serverless Lambda function, which actually sent a notification to my email. But it can be anything else. You can bring it into the UI. You can send it to your mobile device. It can be any type of notification. Okay, so let's start with how you set up the device. A quick start. I will not go deep into every step. I'll just share the link where you can see in details how things happen. But okay, how you set up the Raspberry Pi. First, you need to download the image from the Raspberry Pi website, upload it to install it to an SD card, and run the Raspberry Pi. It's very important to enable first the SSH and enable all other networking interfaces and communication interfaces. You need to enable the camera, enable the SPI and GPIO, all other things that you want to use. And yeah, there is a steps you need to follow. The first thing is to check if the Java runtime is installed. If not, first install the Java runtime and then start deploying all those services that will make this device Kura enabled. You'll have like a running gateway on it. And the next bit is okay, when you make sure that this device is set up correctly, is running, you will be able to access the administration dashboard, admin UI. So I will show you how it looks like. And after that, you need to be able to set up your workspace. There is a different ways how to do it. They explain it pretty well into their website. But usually I do it with OMP installer. It's much easy. It's very easy, very smooth, and usually works from the first time. And what actually the OMP installer will do is to install you all the dependencies, all the packages that you need in order to remotely connect to the device and start developing software and pushing on it. Of course, the packages can be signed, so no other person can commit software to your device. And when you do that, ensure that everything is working correctly, smoothly, so you'll be able to build the code, pack it into a bundle, create a deployment package, and push it to the device. You can do it directly from your machine, or have a cloud service that will manage this for you. For example, Eclipse Kura will manage this for you. And for the cloud connection, you have, as I say in the beginning, you have different providers, adapters, and you can use like Eurotech, you can use Amazon Cloud, you can use Azure IoT, Eclipse Kura, and Hono project. So after we set up the hardware, we install the operational system. In our case, is the latest Raspbian. After that, we install Eclipse Kura, so the device now it's enabled as a gateway. We can connect remotely to it. We can follow the heartbeat of the device. We can push software back and forth. And after that, we make sure that everything is running correctly. We need to install the REKOGNITION SDK. This is the tools that use the camera, get the video stream out of the camera, and stream it to the cloud provider that will process this data. AWS, Google, Azure, or whatever works for you best. In our case, I'm using AWS. So you can see the GitHub. You have different profiles. You can install it on Linux. You can also run it on Mac. You can also run it on Windows. Yeah, it's really flexible and runs everywhere. The core software is C++, but you have a Java wrapper for it. And okay, so we can go through the most interesting part, the demo. I call it the Sauron Eye. Okay, so I've already pre-run the software just in case. You can see the red light, the small red light on the camera. This is the battery pack. Okay, so let me see. I'll show you. How can I move my browser to the other screen? Yeah, I'm trying, but it's not. Yes. Okay. Okay. Hop. Yes. So this is what the camera sees now. The internet connection is not so good, so perhaps there will be a latency. Okay. I also want to. Okay. So, and I will show you what is the response from the camera. Currently, everything is sent to my email. So, you can see now the camera found 5 or 6 unknown people. So you can see it's streaming all the time. The video processing engine is processing in real time and send me feedback instantly. Okay, so yeah, it's streaming all the time. Let's see now. Oh, now found 9 unknown persons. Okay, now let's try with my face. Let's see what it will say. Okay. Let's see. Oh, yes. Okay. So now you can see the payload. Yes. I will just push it in something that you can see the data, how it looks like. Viewer. Okay, so this is what actually returns from the data analytics. You can see the matched faces and detected faces. You can see on the bottom, I've already pre-upload some of pictures of me in S3 bucket. So anytime, so all the time when the camera is streaming, the engine is comparing all the faces that match with my profile. And yeah, you can see the external image ID, how the percentage of how confident is the system that this is me. And yeah, you can also see a lot of interesting data inside this object, which can you can do actually a really interesting thing with it. Not only faces, but it can recognize objects. It recognize scenes. It can recognize how your emotion change in time. So perhaps you can, for example, you can watch some movie. The system will recognize, okay, how sad are you? How percentage of feeling okay? Are you feeling good? Yeah, and actually there's a companies that are doing this. Let's say from the telecoms, you have a set-top box or stuff. You have a smart TV that have a camera on it. And actually they analyze your behavior and your emotions while you're watching advertisement or anything else. Or when you go to the gas stations, there is a, there is a tablet with camera says, okay, I see you. So actually when you watch the advertisement, they analyze your emotions in real time. And yeah, you can see how much benefits you can have from this one, from services like this. Okay. Let's move this thing away. Let's go back to the presentation. On the other side. Okay, so yeah, this was pretty much the demo. And let's see, just a second. Yes, yeah. This is for me. It's also very fresh. It's very new. So if someone of you is dealing with such technologies and going in that direction, I'll be happy to chat with him. And yeah, also I want to maybe I can share some of our latest projects that we did in the area of Internet of Things and artificial intelligence. Our last project is for a vineyard where we managed to save more than €1,600 per month in matter of electricity and water consumption. This is for around 16,000 square meters, and the project value is less than €1K in euro. So from the first year, the project pay itself, and yeah, continue evolving. The technology that we was using for it is we have a lot of sensors for soil humidity on different levels. So you can see actually how this thing works. We measure the where is the water when we're watering the plants, and okay, when it reach the sensor number 3, we cut it, and we use algorithms to predict how much and when we should irrigating the plants. We're using the weather forecast, and okay, so now we know if the humidity in the soil is 30%, and let's say in 2 days will rain, we will not irrigate the plants until it's a huge success. And yeah, we buy the sensors. How many? There are 3 of them. Yes, it's depending actually on the type of the soil, because when we're measuring the soil, okay, if it's one type, so you know that the soil drains the same level on, so you don't need more. But if you grow on hills or you grow somewhere else, you need to have more sensors. But yeah, before you start, you will already know what the type of soil is, so you have like a different, you know where to put your sensors. And yeah, I have some pictures, and also how the system looks like. This is just a dashboard for visualizing. Everything is serverless, which we managed to run serverless on premise and serverless in the cloud, which is yeah. And yeah, on the other project that I want to share with you, it's for a fish farm that we work on it. And the main problem that the company had is with the water quality, because they was using very old and ancient techniques to measure the water quality parameters like the oxygen, pH, and other parameters that are very important for the fish. And the type of fish that they were growing was very sensitive to the oxygen in the water. If the oxygen level drops at certain level, you can lose the entire population very fast. So what they used to do, they have a boat, they fire up the boat, go there, get sample from the water, bring it back to the shore, analyze it, and put it into the big books. So yeah, we start small with a floating buoy. We put some sensors on it. It runs again on low power wireless network. We use LoRa for transmitting the messages over the water, but it can be tricky for the frequency. And we use 433. And after that, we 3D print a floating buoy, put all the sensors that we need. Currently, we're running on dissolved oxygen, pH, and temperature. This is the 3 most important factors for the company. And yeah, you can see how the interface looks like in the bottom. But one of the most important things that we did here is the actual transformation, digital transformation for the business, because before everything happened in the big Excel spreadsheets. You can put the food, you can put how much food you buy, how many fishes you have, and all the parameters goes in there, and very complex calculations. And in the end, like you can't predict the outcome of your business. In the end of the year, are we gonna win some money or are we gonna lose? So we put everything inside. Artificial intelligence algorithm try to predict this. The outcome of the whole year. Okay, so depending on the weather, depending on how many fish you have in the lake, what is the water quantities, water parameters, and yeah, it's also very, very nice. And yes, I think that's all from me. If you have any questions or you just want to talk about something, and I'll be happy to. Yes? Yes, it's Amazon service. Yes, but also include in a free trial, so you can try it without paying much. So it's the Amazon REKOGNITION, the blue one. For facial recognition, perhaps there is, but yeah, I never tried them. I start with this one, just to make sure that the things I'm doing they really work, and in the end it works pretty well. But yeah, it requires a good internet connection and a bandwidth. Yeah. Any more questions? Yeah.
Yeah, I was looking at irrigation models.
Yep.
Do you also use Amazon models for that, or do you, for instance, use TensorFlow or train your own models? How do you?
We train our own models.
Yeah. Okay. Which platform do you use?
They're actually they're developing Mathematica 5. It's
Okay. Yeah. We'll check it out.
yep. Yep. For the image processing. No, for Arduino, no. It's you need operational system to run on it. You need some kind of Linux, or you can run it in an emulator on your machine, just to try the things, just to get a taste of how it looks and how it works. More questions? Yes?
What kind of lifetime do you get from the floating object you described?
Yes?
What kind of battery lifetime you
We have a small solar panel on top of it, so yeah, it's very, very low consumption because we are using the LoRa technology to transmit messages. So most of the time, the actual MCU is in sleep mode. So wake ups every hour, or the last time I think it's every 45 minutes. It wakes up, take the measures actually, because you don't power the sensors all the time in order to save power. It wakes up, takes the measure, send it over the network 3 times, and then sleep again. But you have uplink. You can send messages to the gateway. The actual gateway that receiving the messages from all of the nodes is actually a Raspberry Pi running on Kura. And receiving the messages, and also you have downlink. When this device connects to the gateway to send message, the gateway can send a message back. So we can adjust this time period. So let's say we can change the update time as we want it. Or you can define any downlink messages you want to handle. So let's say you want something to happen now. When the device connects, you already register that you want to do something on the node, and yeah, it will execute the command that you want. And the channel is encrypted end to end. No, the data encryption comes from the protocol, LoRaWAN. He handles the encryption of the messages. And then when the gateway receives the messages, it pushes back to the cloud or on-premise server, or let's say if you're using some LoRa service provider. It's entirely depend on how your setup looks like. More questions? Okay, so yeah, if you want to just get in contact or say hi, this is my details. Thank you.